Hello everyone, welcome back to my YouTube channel. Today's topic is selection sort. Before starting topic, please like, subscribe my YouTube channel. First we learn how this algorithm will work. In selection sort, we can draw an array and insert the element, and then n is equals to length of the array. And this n will store the total number of elements in the array. We will use this for loop limits. For I from 0 to n minus 2 means outer loop that goes through each position in the array, that is except the last one. At each I, the algorithm tries to place the correct minimum element there. Here minimum index equals to I means assume the current position I holds the smallest value. This will be updated if the smaller element is found in the loop. For j from I to I plus 1 to n minus 1 means inner loop that scans the unsorted part of the array elements to the right one, and it looks for the smallest element in the remaining array. Next, if array of j is less than array of min index means check if the current element array j is smaller than the current minimum. If yes, update the min index. Min index equals to j means update the index of smallest element found so far. And n if or else if min index is not equals to I means after the inner loop check if the smallest element is already at the current position. If not, swap if needed. Swap array I and array min index. Swap the smallest element found with the current element at the index I. Here are the steps to solve the problem. Let me take an example, that is 29, 10, 14, 37 and 13. We need to sort this array in ascending order. First shall we compare. Assume 29 index 0 is the smallest. Compare with 10 and 10 is the smaller. Update minimum index equals to 1. Compare with 14 and 10 and is still smaller. And compare 37 and 10. 10 is still smaller, and 10 is still smaller. And swap 29 with 10, and result will be 10, 29, 14, 37 and 13 for the first swap. Assume 29 is the smallest and compare 14 is smaller. Minimum index will be 2. Compare 39 with 14 is still smaller is 14. Compare 13 with 13 is smaller, minimum index will be 4, and swap 29 with 13. After 10, 39 is the smaller in that array, so swap 29 with 13 and result will be 10, 13, 29, 14, 37. 14, 37, 29. And next swap is assume 14 is the smallest. Compare the 13, there will be no change, and compare with 29, there will be no change, and no need to swap 10, 13, 14 and 37, 29. And next swap 37 is the smallest and compare this with 29 and 29 is the smaller. Minimum index will be for 29 is 4, and swap this 37 with 29 because 29 is smaller than 37, so swap 37 with 29 and result will be 10, 13, 14, 29 and 37. Only one element is left, that is already placed, and the array is sorted in 10, 13, 14, 29 and 37. For this, the time complexity of this selection sort, in best case it will be O of n square, and average case will be also O of n square. Worst case is O of n square. N square is the time complexity for the selection sort. How it works, the total work n minus 1 plus n minus 2 and plus n minus 3 so on plus 1 plus 0. This is an arithmetic series, so sum will be n of n minus 1 by 2. The number of comparison about n square by 2. This gives O of n square. The time complexity of this selection sort will be n square. Thank you.